Okay, so Chapter 1, Lesson 2 is complex fractions and unit rates. Now, in the warm-up, it says here, Dana is skating laps to train for a speed skating competition. She can skate 1 lap in 40 seconds. Number 1 says to write a ratio in simplest form, comparing Dana's time to her number of laps. So we're comparing time to laps, right? So her time was 40 seconds, and the number of laps was 1. So that's 40 to 1, and that's your ratio. Is everybody clear? All right, now suppose Dana skates for 20 seconds. How many laps will she skate? Well, let's see, 20 seconds is half of 40, right? So if I divide this by 2, I'd have to divide this one down here by 2, right? So that would give me half a lap, right? She would do in 20 seconds, she would do half a lap, right? This number 3 says, write the ratio of Dana's time from exercise 2 to her number of laps. So and again, we're doing time to laps, right? So Dana's time for exercise 2 would be how many? 20 seconds, and then half a lap. This is what we call a complex fraction. Okay, this is what we call a complex fraction. A complex fraction is a fraction that has fractions in either both the numerator and the denominator, or a whole number and a fraction in either one of them. Okay, so how could we simplify the ratio that we wrote in exercise 3? Okay, so here we could divide 20 by 1/2. Now, when what does a fraction bar mean? The fraction bar means divide, right? That means divide. So this says 20 divided by 1/2. So if this is 20 divided by 1/2, just as a reminder, what do I do when I'm dividing fractions? We multiply by the reciprocal. So that means that we can multiply by 2/1. Is everybody clear with that? And then we would end up with 40. All right, so the next part is to simplify a complex fraction. Please make sure you write down this definition, the red and the blue. Complex fractions are fractions with a numerator, denominator, or both that are also fractions. Complex fractions are simplified when both numerator and the denominator are integers. So for example 1, it says simplify 1/4 over 2. You see how the fraction bar right here that is bigger than this fraction bar? Does everybody see that? So that tells you that this is the numerator and this is the denominator. Is everybody clear? All right. So you just have to check to see which one where's the bigger fraction bar, okay? So this says 1/4 divided by 2, because 1/4 over 2 is 1/4 divided by 2. So then when we are dividing with fractions, we multiply by the reciprocal. So that's going to end up 1/4 times 1/2, because the reciprocal of 2/1 is 1/2, okay? So, and then we simplify to 1/8. Same thing with example 2. This is the numerator, and this is the denominator, okay? So we've got 1 divided by 1/2. And again, 1 divided by 1/2, we multiply by the reciprocal, and we end up with 2. So for this first example, for this first got it example, we've got 2 over 2/3. 2 over 2/3. So that means that's going to be 2 divided by 2/3. So this is how we're going to show our work. You're going to write the original problem, then you're going to rewrite it as a division problem. So that's 2 divided by 2/3. Okay? Now, when we are dividing fractions, we know that's going to be multiplying by the reciprocal. So this is going to be 2 times what? 3 halves. Very good. 3 halves. Now, if you need to, you can put the 2, the first one, over 1. Oh, I'm sorry. Yeah. That's supposed to be a 2. Yeah. So that 1 was supposed to be a 2. So we have 2 over 1 times 3 over 2. And yes, of course, before you multiply, you should simplify. Very good. So when we simplify, we end up, when we multiply straight across, with 3 over 1, which is just 3. Very good.
It's so easy.
All right, so example C says 2/3 divided by 7. Okay, so this is, we're going to rewrite as division. So that's 2/3 divided by 7. Now, of course, 7 is 7 over 1, right? So when, oopsie. So now we are going to multiply by the reciprocal. So that's 2/3 times what? Very good. 1/7. And now when we, can I simplify before I multiply? No. So we multiply straight across and we end up with 2/21. All right, so now we're going to find unit rates. So when the fractions of a complex fractions represent different units, you can find the unit rate. Because remember, a unit rate is just a comparison of 2 different quantities, right? So whether it be an integer or a fraction, it's still comparing 2 different quantities. It's still a rate. And when it compares to a quantity of 1 item, then it's a unit rate. Okay? So Josiah can jog 1 1/3 miles in 1/4 of an hour. Find his average speed in miles per hour. Okay? So here it says write a rate that compares the number of miles to hours. So we're comparing miles to hours. So here's the miles, 1 1/3 on the top, to hours, 1/4 on the bottom. Now, we're going to rewrite that as division. So that's 1 1/3 divided by 1/4. Okay? So now, before we do the division, we have to change to improper fractions. So here we've got 4/3 divided by 1/4. To simplify this, we multiply by the reciprocal. Very good. And we end up with 6/13 or 5 1/3. So that means that because we divided by 1/4 in the denominator, what are we comparing it to? What's going to be in the denominator if we divide 1/4 by 1/4? That's 1, right? 1/4 divided by 1/4 is 1. So that means that this 5 1/3 is going to be over 1. Does that make sense? So that's how they got the 5 1/3 miles per 1 hour. Mr. Ito is spreading mulch in his yard. He spreads 4 2/3 square yards in 2 hours. How many square yards can he mulch per hour? So, what are we comparing? We're comparing yards squared to hours. Very good. So, we're going to write our original ratio. So, that's going to be 4 2/3 yards squared in 2 hours. So now we're going to write this as a division problem. So this is going to be 4 2/3 divided by what? 2 over 1, right? We can put that over 1 like that. Okay? So now, before we do this calculation, we have to change to improper fractions. So that's going to be 12, 13, 14 thirds divided by 2 over 1. And now we're going to multiply by the reciprocal. So 14/3 times 1/2. Is everybody clear? Now, before I multiply, I can simplify. Very good. So 2 divided by 2 is, and 14 divided by 2 is 7. So when we multiply straight across, we get 7 over 3. So this is going to be, when I simplify 7/3, that's going to be 2 and, oops, that's going to be 2 and 1/3. 2 and 1/3 what? Yards squared. Yards squared over what? 1 hour. Very good. Example 5 says, on Javier's soccer team, about 33 and 1/3% of the players have scored a goal. Write 33 and 1/3 as a fraction in simplest form. Okay? Now, if I did 1/3, that would be, if I wrote that as a decimal, of course, that would be a repeating decimal, right? So, here, what we're doing is we're writing it as a fraction. So 33 and 1/3%, percent is always over 100. Percent is always over 100. Okay? So, the first thing you're going to do with the 33 and 1/3% is write it 33 and 1/3 over 100. Then, of course, this fraction bar means divide. So we have 33 and 1/3 divided by 100. So when we do that, we're going to multiply by the reciprocal. So here we had to change the 33 and 1/3 to an improper fraction. So 33 times 33 is 30. So 33 times 3 is 99, plus 1 is 100, so that's going to be 100 over 3. Then we're going to divide by 1. Of course, we can put this over 1, then we can multiply by the reciprocal. Then, before we multiply, we can simplify. And we end up with 1/3. Is everybody clear? All right, very good. So let's do one together. So here, we've got county sales tax. County sales tax is 6 2/3%, and we want to write that percent as a fraction in simplest form. And again, percent is always over 100. So we have 6 2/3 over 100. And now we can change that to a division and simplify. Okay? So 6 2/3 divided by 100. So, first thing we do before we do our calculations is change this to an improper fraction. So 6 times 3 is 18, plus 2 is 20. So we've got 20 over 3 divided by 100. And then we, of course, can write that over 1 so we can see what the reciprocal is going to be. So now we multiply by the reciprocal. So we have 20/3 times 1 over 100. And of course, before we multiply, we can simplify. So 20 divided by 20 is 1. And 100 divided by 20 is 5. And then when we multiply straight across, we get 1/15. Very good. So 6 2/3% as a fraction in simplest form is 1/15. All right, so let's do example B. Here, example B says 6 divided by 1/3. 6 over 1/3. So the first thing we're going to do is we are going to rewrite this as a division problem. So we have 6 divided by 1/3. So now we're going to, when we divide fractions, we're going to multiply by the reciprocal. Okay? So the reciprocal of 1/3 is 3. So we have 6 times 3 over 1, right? If you want to put this over 1 also, you can do that. But since they're both whole numbers, we didn't even really need to put them over 1, right? So here, 6 times 3 is 18. And there's your final answer. All right, example D says 2/4 over 2. So when we rewrite that as a division problem, we have 2/4 divided by 2, right? And again, we can put this over 1. All right, so now we are going to multiply by the reciprocal. So we've got 2/4 times the reciprocal of 2 over 1 is 1/2. And now, before we multiply, we can simplify. So the 2's cancel both 2 1's. And when we multiply straight across, we end up with 1/4. Very good. So now, all right, so Tia is painting her house. She paints 34.5 square feet in 3/4 an hour. At this rate, how many square feet can she paint each hour? So first thing we're going to do is we're going to write a ratio that compares the number of square feet to the number of hours. So that's 3.5 square feet to 3/4 of an hour. Now there is my complex fraction. Okay, so we're going to first change that complex fraction to a division problem. So that's going to be 34 and 1/2 divided by 3/4. Now before we do the calculations with this division, we have to change the mixed numbers to improper fractions. Okay, so that's going to give me 69/2 divided by 3/4, and now we can multiply by the reciprocal. Okay, so 69/2 times the reciprocal of 3/4 is 4/3. And then we end up with 276/6, which simplifies to 46. And this 46 represents the square feet. Very good. Now, what I want to bring to your attention there is that's 46 square feet. This would be over 1. Does everybody see that? Because if I divide 3/4 divided by 3/4, what do I get? 1. And that's why this is going to be 1 hour in the denominator. Does that make sense? All right, very good. So Aubrey can walk 4 1/4 miles in 1.5 hours. Find her average speed in miles per hour. So we're comparing miles to hours. Very good. So first thing we're going to do is we're going to write our fraction, our complex fraction. So that's going to be 4.5 miles in 1.5 hours. Okay? So now we're going to change this complex fraction to a division. Okay? So this is going to be 4 1/2 divided by 1 1/2. Now before I do my calculations, I have to change all of my mixed numbers to improper fractions. Very good. So this is going to be 8 9/2, and we're going to divide by 2 3/2. And now it's simple division, right? So when we divide fractions, we multiply by the reciprocal. Very good. So we're going to multiply by the reciprocal of 3/2, which is 2/3. Very good. And again, before we multiply, we can? Very good. Simplify. So the 2's cancel to 1's. And the 3 and the 9, 3 divided by 3 is 1, and 9 divided by 3 is 3. So when we multiply straight across, what do we get? Very good. It's going to be 3 over 1. What are my units going to be? Very good. This is going to be 3 miles in 1 hour. Is everybody clear? Let's see.